Hi, and today we are going to be going over the video tutorial for the homework for week 3. That is going to be our first triangle homework. So it's called Paper Plotting Homework 1, and we got 10 questions, and we're just going to plot it up to the first triangle. We're not going to do the second triangle. But let's get started with our homework 1, or yeah, it's called homework 1, but it's for week 3. Okay, so like we did in class, we're just going to plot what they tell us, and then we're going to answer those questions. So they told us our own ship is on course 000, so I'll write this. Own ship is 000 with a speed of 12 knots. So I'm going to put in a heading flasher line. So that is my heading flasher, and I'm going 12 knots. Then they told us 3 times where we got a bearing and a range to a few targets. So we're going to plot those. Our first one is bearing 035 at 11.1. So 035 at 11.1. So we're going to label that R, and that was at 0410. Then they gave us at 4:16, 6 minutes later, we have a bearing of 031 at 9.2. So 031 at 9.2. So plot this. And that is going to be our M at 0416. Now they did give us another one. I'm just going to plot it. I want to keep my triangle in the 6 minutes, so it's a little bit easier for me to do that 60D street calculation. But I'm going to plot the other one just to see the tendency here. So 025 at 7.3. 025 at 7. So somewhere over here. 7.3. So that was at 0422. So if we connect all of these lines from R to M to our next one, they do all connect. They all line up there. Let me draw it with a big pencil so we can get it. Okay, so that's our relative motion line. And well, I guess we'll start answering some questions. So question A was, what is the distance the contact will cross ahead of your vessel? So that's going to be that bow crossing. So right where it crosses our bow is right there. So we're going to measure that distance. So it's a little over 4 miles. Let's see what it would be. About 4.2 or 4.3. Yeah, 4.3 would be our bow crossing. And then ask us, what is the direction of the relative motion line? And what is the speed of relative motion? So we have to parallel that relative motion line back to 0, or back to the center, so that we can read it. That's just how the plotting sheet works. So we have 2, 33, 34, we'll call it a direction of relative motion of 234 degrees, a speed of relative motion, and we want to plot what's going to happen. The distance of relative motion in 6 minutes is exactly 2 nautical miles. So we do a quick 60 Street, 6 minutes, you just move the decimal place over 1. So that would give us a speed of relative motion of 20 knots, because our distance there was 2 nautical miles, 2.0. So you just move that decimal place over 1. Okay. What is the distance and true bearing of our CPA? So our CPA is the closest point of approach. So I use the 90 degree on the triangle. From the center, line that up on the relative motion line, and I get a CPA right here. My bearing of the CPA is 324. So we'll say 324 degrees at a distance of 3.5 nautical miles. And then we also want to get the time of the CPA. Actually, is that a question? It is a question. Before that, though, what is the distance from our 422 plotted position of the contact to the CPA? So what is the distance from the contact position to the CPA? How much more traveling distance do they have until we get to our closest point of approach? So we're just going to measure that out. And we have about 6.4. It's not really called anything. .4 nautical miles. But what we were looking for was our time. So we had our 6 minutes. Okay. So we got 6 minutes on the divider, so we have 22. Make our little 6-minute lines. Then I'll do that math. Okay. So we have 22 plus 6 would be 0428. This would be 28 plus 6, 34, 40, 46. So just past 40. So I'd call our CPA 0441 for our time of CPA. Then it says, what is the distance our own ship travels between 0410 and 0422? What is the true course of the contact? What is the distance run by the contact between those times? What is the speed of the contact? So they want to know for us, how far would we have traveled in the 12 minutes? So I guess I'm going to make it a 12-minute triangle. But 12 minutes is still very easy. We are going 12 knots. So if we were going 6 minutes, we would travel 1.2 nautical miles. And we're doubling that in 12 minutes. So we would travel 2.4 nautical miles. So that's in 6 minutes, we would travel 1.2 nautical miles. So we double that. In 12 minutes, we travel 2.4 nautical miles. So if we're doing our 6-minute triangle, we make our line from R and we make a 2.4. So I'm doing that 12-mile triangle, or 12-minute triangle. 2.4. So that would be our E. And we're doing 12 minutes, so that would be this guy here would be our M. Because this is in 12 minutes, so we want our R to M in 12 minutes. So we have our R, or E to R, which is us, our own ship. So we're traveling 2.4 nautical miles in 12 minutes at a course of 0, 0, 0. So we're going this way. We have a relative motion line, and then we have E to M is them. So let's see what they are doing. Bring that down to the center. Okay, so we got a true course for them of 268. So I got 268 is their course. And then I want to know what their speed is as well. So I'll get my distance. That is how far I'd gone in 12 minutes, which is also one of our answers here. So 3.3. This is 3.3 nautical miles. So we want to switch that to speed. So let's try our 60D street out. We can do our circle, 60D ST. Our distance was 3.3. We're looking for our speed, and our time was 12 minutes. So we'll get our calculator, and we can see we can do the two things that we have are on the top. So 60 times 3.3 divided by 12 gives us a speed of 16.5 knots. So that would be our speed. And that is the answers for number 1. All right, we're going to time. Okay, so now we're on number 2, and we have our own ship is on course 030 at a speed of 23 knots. So we'll plot that first. We have 030. So own ship is 030 at 23 knots. Then we have three bearings again. So we'll plot all of those. 081 at 10.8 miles. So 081 at 10.8. So that is going to be our R. And that was at 10:20. Next one, 082 at 9.2. This was 10:23, and then we have 083 at 7.7. This was 8, 7, 5. Alright, so here we're going to call that our R, and that was at 10:26. So we do have a 6, oops, that's our M. We have our R and our M, and we do have one in between. We don't necessarily need it. So that's what they told us. Assuming the ship and the other vessel maintain course and speed, answer the following questions. So A, what is the distance and bearing of our CPA? So our first step is to draw in the relative motion line. So we're going to connect R and M, and our middle one, they all connect here. This is our relative motion line. To get CPA, that is going to be 90 degrees from our relative motion line. So using that 90 degree on the triangle, I'll draw in. My CPA is going to be bearing about 166. At a distance of 1 nautical mile. All right. And then they ask us, what is our speed of relative motion? They don't ask us for direction, but we can both. Direction of relative motion and speed of relative motion. So for direction, we have a relative motion line, and we're going to bring it up to the center so we could measure it. So our direction of relative motion would be 2, 5, 6. Our speed of relative motion, we'll get that distance traveled in 6 minutes. And I got 3.1, so that would make our speed of relative motion 31 knots. Okay. What is our CPA? We figured out our CPA, but what is our time of CPA? So that's 6 minutes. 6, 6, 6. So that was 26. So this would be 32. This would be 38. And this would be 44. I'd say we're right in the middle between those. So our time of CPA would be about 3 minutes plus that. So I'd call it 10:41 as my time of CPA. What is the distance your own ship will run in 6 minutes? So my ship is doing 2.23 knots. So to get my distance in 6 minutes, you move the decimal place over 1. So we would be doing 2.3 nautical miles. So let's draw in our E. We're going to parallel our 30 here. Draw in E. At 2.3 nautical miles. So here is our E. So they asked us, what is the true course of the contact? So E to M is our contact. E to M. I'm going to parallel that down to the center so we can get their true course of about 301, we'll call it. So their true course is 301 degrees. What is the truth? What distance, if any, was run by the contact by the time in the time frame this and this? So basically to figure this out, we're going to figure out the distance here, and then we could figure out the speed of our target as well. So the distance from E to M is 2.3. So we would call that 23 knots is our target speed, 2.3 nautical miles. What is the speed of contact? 23 knots. And then it says, under the rules of the road, may sidelights be exhibited during daylight hours when visibility is limited by weather? So it's just asking a general rule of the road question. And yes, your running lights can be turned on always, whenever. They must be turned on in restricted visibility or from sunset to sunrise. So nighttime hours and restricted visibility, they must, but they may be on all the time. So the answer would be yes to that question. Then it says, what side lights would we see at our CPA, provided you could see the ship side lights? So let's go back to our ships here. So this is us, and this is them. So at 10:26, they are seeing green, and we are seeing red. But they asked us, what would we be seeing at our time of CPA? So if the vessel is still on this heading, and he is below us, what would we be seeing? We would be seeing his green light, his green side light, because we have our green and our red, and he would be behind us. So at CPA, we'd be seeing the green. At 10:26, we were seeing red. At one point, we saw both, and then we saw the green. So, what side light would we see at our CPA? Would be the green side light. Okay, and that is question 2. And I am going to do these, my nieces are up from their nap, so I'm going to do these later this week and post them again, but I'll post the first 2 here. So stand by and email me if you have any questions.